Today we're going to do some solving of problems with two unknowns. We've started solving some linear systems, and we're going to do that some more today with some word problems here. We're going to solve each problem by graphing the system of equations and then checking the solution. So here we have a situation where together Zena and Yolanda have $12. And there's an equation down here that represents that. Zena for X, Yolanda Y. When you add their two amounts of money they have together, they have $12. And then the next one says Yolanda has $6 more than Zena. And there's an equation to represent that. Yolanda has is equal to $6 more than Zena. How much money does each person have? So what they've got here is this is called a linear system. And we're going to solve it by graphing the two equations. Now, the first one, hopefully we're looking at this as that x-intercept is 12 and the y-intercept is 12. Now I made a mistake here because my coordinate plane doesn't go up to 12, but I'll just kind of estimate. I know 11 is at the tip of this arrow, and so I'll just kind of estimate. Draw a straight line between those two. There's the graph of x plus y equals 12. Now in the second equation, the y-intercept is 6, and the slope is 1. So I'll just repeatedly use the slope there, up 1 over 1, up 1 over 1, up 1 over 1. And I'll draw a line there. Now what we're looking for is how much money Zena and Yolanda have. Remember, the sum of their money is 12, and Yolanda has $6 more than Zena. Well, the point where these two lines intersect is the solution to that problem, and they happen to intersect at 3, 3, meaning Yolanda has $3. I'm sorry, 3, 9, meaning Zena has $3 and Yolanda has $9. So let's check our answer. Is the sum of their money $12? Yes, it is. And we also have to check it in the other equation too. Does Yolanda have $6 more than Zena? Sorry. Yes, yes, she does. Okay, so what we do is make two equations, graph those equations, look for where they intersect to figure out the solution to the problem. Let's do this again. In fact, let's do it 3 more times. Nikki is thinking of two numbers. Their sum is 12. Well, that's an easy equation to make. We got one unknown number and another unknown number, and when you add them together, they equal 12. The greater number is double the lesser number. Now, which one's greater? It doesn't really matter, but we'll just go y is the greater number. It equals 2 times the lesser number x. And then we can graph these two equations. Again, on the first equation, we should be looking at this like the x and y intercepts are 12. And then in the second one, it's got a y-intercept of 0, and the slope is 2. So I'm going to go from the origin up 2 over 1, up 2 over 1, up 2 over 1 repetitively. And then I'll draw a line. Now we already kind of know where they intersect, but I'll finish drawing my lines anyway. They look like they intersect at 4, 8. So those are the two numbers. And let's check it. Is the sum of these two numbers 12? Yes, it is. And is the greater number equal to 2 times the, or double the lesser number? Yes, it is. All right, now one thing to note while we're at this point, though, is that when you're graphing linear systems, and that is 2 or more equations, to try and find the solution, you have to have really nice graphs. Your lines have to be really straight, and your scaling on your coordinate planes needs to be very accurate. Let's try another. This says use inspection to predict the solutions to the system of equations, and then we're going to graph the equations to verify our prediction. So we're just looking at this. It says x plus y is 6 and y equals x. So the sum of two numbers is 6, and those two numbers are equal to each other. So what are the only two numbers that add up to 6 that are equal to each other? And so we're going to use inspection and say, well, 3 plus 3 is 6, and 3 equals 3. So the solution must be x is 3 and y is 3. Now let's graph these two equations to make sure. On the first equation, the x-intercept, the x and y-intercepts are both 6. Draw a line through those two points. And on the second equation, the y-intercept is 0 and the slope is 1, so I'll go up 1 over 1. and draw a line through those those many points I made. I only really need 2 points to make a line, but you'll see where these two lines intersect each other. They intersect each other at the point 3, 3. Describe two numbers represented by this system of equations, then graph to find the two numbers. Okay, describe two numbers represented by the system of equations. So they want us to actually talk about these two equations. What are they saying? Well, the first one I'm going to say y is 6 less than x. That's what that first equation says. It says y is 6 less than x. And, because we have a second equation, the sum of x and y is 0. Okay, so that's what this system of equations says. It says that one number, y, is 6 less than the other number, x, and it also says that the sum of the two numbers are 0. All right, so let's graph these two equations. The first one, it's got a y-intercept of -6, -6 right there, and it's got a slope of 1. I can just use that slope as many times as I want, get a nice straight line. Okay, and then my second one, the x and y intercepts are both 0, so that doesn't really help me. But I do know that the sum of the two numbers is 0. These numbers are opposites of each other, like 1 and -1. Well, 0, 0 obviously is 0. 1 plus -1 is 0. 2 plus -2 is 0. 3 plus -3 is 0, and so on. Draw a line through those points. And we got our point of intersection. So looks like 3, -3. And we can check that answer because we know that 3 minus 6 is -3. And we also know that 3 plus -3 is 0. All right. I don't know, kind of a fun lesson today for me to teach anyway. Hopefully for you to learn too. You graph a couple of lines, look where they intersect, and you got to be good at graphing lines, or else you're never going to get where they intersect if you're graphing the wrong lines. So I'm assuming that we've gotten a lot better at that over the last few lessons. Let's give it a shot tomorrow. I'll see you then.